Welcome, everyone. You've definitely heard the name Albert Einstein, the genius who gave us E=mc². But today, we're diving into a story you might not know, what he did after he became the most famous scientist on the planet. After he had already reshaped our entire understanding of reality by uniting space and time, he got consumed by one final obsession, one that would last for 30 years. All right, so let's get into it. After changing everything we thought we knew about space, time, and gravity, Einstein didn't just, take a victory lap. That just wasn't his style. He took that same incredible curiosity and aimed it at an even bigger prize, a single theory that could explain everything, the final peak of physics as he saw it. So having already unified space and time into this single thing called space-time, he spent the last 3 decades of his life on this one single quest to unite the two great forces of nature known at the time, that's gravity and electromagnetism, into one beautiful, overarching theory. What he was really searching for, at its heart, was one master set of equations to govern the entire universe. He called it a single logical building, something that could explain everything from the majestic orbit of a planet all the way down to the simple flicker of a light bulb. Now, to really get the scale of this ambition, you have to remember just how much he'd already changed the world. With special relativity, he completely demolished the old idea of absolute space and time. He showed they were fused together into a single four-dimensional fabric, space-time. And then, with general relativity, he redefined gravity itself. It wasn't some mysterious force pulling us down. Nope. It was just the curvature of that space-time fabric, caused by mass and energy. As one physicist put it, space-time tells matter how to move, matter tells space-time how to curve. For Einstein, these huge achievements were just the warm-up. This next challenge, though, it would be a much longer and ultimately more solitary journey. Einstein was absolutely convinced that the secret language of the universe was geometry. I mean, he'd already shown that gravity was the geometry of space-time, so he figured a more complex geometry could also explain electromagnetism. The problem was, finding the right one was like trying to navigate a maze of incredibly abstract, mind-bending mathematical ideas. And he wasn't alone in this, not at first anyway. The 1920s saw this just chaotic explosion of different mathematical approaches. You had brilliant minds from all over the world, Weil, Eddington, Kaluza, Schouten, all proposing these new frameworks, new languages for describing curved spaces, and each one was hoping they had found the key to unlock the universe's final secret. This quote right here really shows you how rigorous Einstein was. He would dive into these ideas, explore them completely, but as his letter shows, he found them all lacking, one by one. See, for him, it wasn't enough for a theory to be mathematically beautiful. It had to actually connect to the real world. It had to be, as he put it, physically useful. If the math didn't describe the reality we see, he would just toss it out, no matter how elegant it was. Now, one of the most mind-bending of all these attempts came not from some famous physicist, but from a then-unknown mathematician named Theodore Kaluza. He sent his idea to Einstein in a letter, and it was just breathtakingly bold. He proposed something completely radical. What if our universe has more dimensions than the 4 we can actually see? 3 of space and 1 of time. What if there was a tiny 5th dimension, curled up so small that it's completely invisible to us? And this just shows the sheer elegance of the idea. It's brilliant. You don't have to force the 2 forces together. You just write down the equations for gravity in 5 dimensions. And when you unpack them back into our 4 dimensions, the equations for gravity and electromagnetism just pop out. It was almost too good to be true. And, well, in the end, it was. It was too good to be true. While it was mathematically stunning, the Kaluza-Klein theory just couldn't explain the properties of real-world particles. For instance, it had no answer for why an electron and a proton have such wildly different masses. It was a beautiful idea for sure, but the real universe was just more complicated. So Einstein's search continued. But while Einstein was hunting for his unified theory in the abstract world of geometry, a totally different revolution was taking physics by storm. And this one would change everything: quantum mechanics. This new theory was incredibly successful. I mean, it was amazing at predicting how this subatomic world behaved, but it described a universe that was fundamentally built on chance, on probability, and on the weirdness of observation. And that vision clashed big time with Einstein's core belief in an orderly, predictable, and objective reality. So this created this deep philosophical divide. The new generation of physicists, they all jumped on the quantum bandwagon Because, well, it worked. It made astonishingly accurate predictions. But for Einstein, a theory built on probability meant that reality itself was fuzzy and uncertain until you looked at it. He famously said, God does not play dice. He just could not accept it. He believed quantum theory was just a temporary fix, a stepping stone to the deeper, deterministic reality that his unified field theory would one day reveal. And so, for the rest of his life, Einstein kept working. But now, he was pretty much alone. He held firm to his classical vision of a deeper, unified reality, even as most of his colleagues moved on, convinced he was chasing a ghost. He would dedicate more than 30 years of his life to this one single problem. For those 30-plus years, from the 1920s all the way until he died in 1955, he published paper after paper. He explored one complex mathematical path after another. He would announce he was making progress, only to find a flaw later on and have to start all over again. He never found that final, master theory he was so desperately searching for. But here's the thing, he knew exactly what he was doing. This quote, it shows he understood that his search for the ultimate, simple, elegant theory was taking him further and further away from stuff that could be easily tested in a lab. But to him, that trade-off was worth it. The pursuit of this deep, logical truth was an absolutely necessary endeavor. He never did succeed in his grand ambition. His final decades are often seen as this noble but ultimately fruitless struggle against the unstoppable tide of quantum physics, an unfinished symphony from one of the greatest minds in history. But that leaves us with a really fascinating question to think about. Was his quest a failure? Or did his lonely 30-year search for a theory of everything just set the stage for the next generation? I mean, modern physics, with things like string theory, is still grappling with the exact same question Einstein was asking. So maybe his unfinished symphony is still being written.